So I think it should be all right with you. Professor Rajdeep,
Okay.
if I need to co-host in case of any connection issue, normally it won't happen. So I'm making you co-host, Rajdeep.
Yeah, sure. Fine.
Thank you so much. Yeah, so Pooja, are we on live?
Sure, sir. We are on live.
Thank you. Okay, now it is 3:30 in India, and yes, good morning to all the viewers from South Africa, and good afternoon for the viewers in India. On behalf of Indian Physics Association, Roorkee chapter, I, Anil Kumar Gaurishetty, welcome you all to this guest lecture by Professor James Larkin on the Rhisotope Project. So it is my pleasure to introduce today's speaker. Professor Larkin is presently Director, Radiation and Health Physics Unit at the University of the Witwatersrand. He is also the chairman of the university's mandated Institutional Biosafety Committee and is a past chairman of the International Atomic Energy Agency, International Nuclear Security Education Network. He still continues to be heavily involved in international nuclear security education, and over the past 10 years, he has been to more than 10 different countries to share his nuclear security knowledge and experiences with national, regional, and international audiences. He works closely with both the International Atomic Energy Agency's sections on nuclear security and nuclear knowledge management, and most recently on an international nuclear safeguards qualification currently under development. And at Witwatersrand University, he teaches various courses in nuclear security, radiation protection, and nuclear facility leadership, and acts as the university's radiation safety officer. Professor Larkin is a fellow of the Royal Society of Medicine. He is a member of the Institute for Nuclear Materials Management, US, and a founding member of the Southern African Radiation Protection Association. So with this brief introduction, I request Professor Larkin to start his talk on the Rhisotope Project and the role of nuclear sciences. Professor Larkin, now.
Thank you very much for that kind introduction. Let me just share the screen and we can then get this program.
Yes, it's perfectly visible.
Right, let's just do that. Can you see that, or has it?
Yeah, we are able to see, but maybe you can go for full mode presentation, full screen presentation. Yeah, now it's perfect.
How's that? That's perfect. Thank you very much. It's always a complication when you're sharing screens and you're using multiple screens. Anyway, ladies and gentlemen, thank you for joining me. I'm looking forward to making this presentation about the Rhisotope Project. It's one of those things, it started as an idea on a piece of paper a while ago, and then eventually I approached an organization called Rosatom to see whether they were interested in funding it. And much to my surprise, in many ways, they said yes. And so this was the birth of the Rhisotope Project, which was early this year, to be honest. We got the funding about the end of December, and then we started forward. And so that's the creation of the Rhisotope Project. Now, forgive me for that. It's a multifaceted project, but I feel like our mission statement, for want of a better word, is to create a lasting and effective means of significantly lowering the numbers of rhino being poached and killed for their horns. Now, it's particularly nice to be able to talk to an Indian audience, because this is not just a problem of Africa or Southern Africa, but is in fact something that is quite close to your home as well, where you are the keepers and the custodians of forget the name, it's the single horn rhino that's indigenous to India. And we need to protect these iconic animals for a number of good reasons, much related to in fact, if you can work it all the way back to things like climate change, because these animals actually have a significant impact on the ecosystem in which they exist. But anyway, let me go on and to sort of take you through this presentation. Hopefully you can jot down some questions if you have, and I know the colleagues are going to be able to feed those back to me, and I will try and answer those towards the end of it. But so let me take you on about the story of the Rhisotope Project. Again, forgive me if this is sort of aimed a bit at South Africa or Southern Africa, but it's equally, I think, important to the populations of rhinos in India. But rhino populations have been hard hit, especially in places like the Kruger National Park. I don't know if you know about it, but it's the jewel in the crown of the national parks in Southern Africa or South Africa, and it's a piece of land perhaps the size of Israel. And there we have lost, due to poaching, 70% of the rhino over the last 9 years. So let me give you a little bit of a background how I got into this, and I'm going to play you a little video just to hopefully you'll be able to hear the sound and get an understanding of where someone who's actually involved in nuclear security and radiation protection gets to be working in this area.
I think there is an issue with the audio.
I'm sorry about that. You should I would carry on. I can tell you about it. That was a video of Hope, a white rhino, which was poached. And the thing is, with poaching, oftentimes they don't kill these animals. I think you need to understand that. And they just end up hacking the horn out, which leads to these horrific injuries. And oftentimes you'll see that actually they are darted using the same techniques that veterinary surgeons use nowadays to immobilize them to carry out normal treatment. But then they will take an axe and quite literally will chop out that horn, which I think you can all agree is an extraordinarily barbaric act by other human beings. This is the story. I'll share this presentation with you later, but this is an animal called Hope. She had 14 separate treatments to try and deal with these wounds where you'll see they've literally chopped out the top half of the skull to remove the two horns. So what is this project, the Rhisotope Project? Well, it's aimed, and I'll go through it quite quickly because some of this is not going to be of much interest to you, but it's aimed at a number of different things. One, we are looking at demand reduction and horn devaluation. We also then, as falling under this whole umbrella, we're looking at a sort of community upliftment and investment process and education. And then we're also trying to accumulate basic rhino data because there is a significant lack of data on these animals when it comes to understanding of the physiology of these animals and things like that. But I'll principally spend my time talking about the demand reduction and horn devaluation because that's where, if you like, the nuclear science is based. And so this basically, the whole project talks about horn demand reduction. And this is going to be done by the insertion of a measured quantity of radioactive material that we will put into the horn. And it's for these following reasons: to reduce the attractiveness of the horn to the end user. So we are, if you like, devaluing the horn. And also any treated horns that are taken will be much easier to detect at additional points in the smuggling chain. If you understand how all of these various animal products are moved from one country to another, you will realize that obviously they're moved illicitly. And by making them radioactive, we make it that much easier to detect these types of materials that are being moved. Now, I believe in India you have quite a significant nuclear security program going, and there you will see at airports, harbours, that sort of thing, there are installed radiation monitors. I'm not sure how many of you have actually seen them, but they are there, and they have all been set up to detect special nuclear material, especially, but are equally capable of detecting radioactive material, various different radioisotopes. And so this is what we are using to actually try and intercept horn that has been smuggled. But also, I think you will understand that when you talk to a general member of the public or someone who understands a little bit about the world and sort of science and things like that, and you say to them, would you like this horn, or would you like this horn-derived artifact that is in fact radioactive? What do you feel their general answer to the members of the public is going to be? My feeling is that they are going to quietly say, thank you, but no. And this is how we perceive that we will be able to devalue the rhino horn, because you have to understand, rhino horn itself is worth something between 50 and 60,000 US dollars per kilogram. I'm not sure what that is in rupees, but I'm sure you can quickly do the calculation. And when you realize that a full-grown rhino horn can weigh in excess of 3 kilograms, you begin to realize that this piece of keratin, which intrinsically has no value as keratin, becomes an extraordinarily valuable object to those people who desire to own it. So that's, if you like, what the basis of the project is, but we will go on and talk a bit more about it. Again, talking about the upliftment, we have recognised, certainly in societies around game farms and places like that, here in Africa, in South Africa, there is a certain amount of money derived from poaching, which is used in the local community. So we've thought, well, if we're going to take something out of that community, let's find ways to put back into that community. And so we have a social upliftment program that we are working with a number of different people. We're also looking at education, because we want to be able to teach the local people that these animals, these iconic animals, are worth far more to them standing up as generators of income through tourism than they are to be poached once off, if you like, which is just a single tranche of money that might come available to a couple of people in the society, in that local area. By having these animals on game farms and places like that, there are much more opportunities for decent wages, for decent salaries, for decent jobs that continue on an ongoing basis. So that's part of the education. But we also got this project which we're calling DigiPal, which is the opportunity for children all around the world to connect with other local schools here in South Africa and elsewhere in the world, and to have a conversation with people elsewhere in the world. So we shorten the line of communication between, if you like, the area where these animals are poached and where the end users are. And I think it's one of these things which would be of equal value in somewhere like India, where the opportunity would to get your children in schools there to be able to talk to people in South Africa, but also in the Far East and places like that. And again, the research data, this is where we are just collecting fundamental physiological data about the rhinos. But I think just to kind of, again, moving things on a little bit, what is the demand for rhino horn? Well, obviously there's the traditional medicine that's is very prevalent in the places like the Far East, but also here in Africa, where there has always been a certain underlying demand for the things like rhino horn, pangolin scales, and various other animal products. And again, there's both the Chinese and the Vietnamese traditional medicines. One of the issues that has driven the demand recently is a belief in Vietnam that rhino horn can actually be used to treat cancer. It's obviously completely fallacious. Had there been any truth to this sort of thing, there's no doubt that the international pharmaceutical companies would have actually analysed rhino horn and looked and found that the active ingredients in it which could be used to treat these types of things. But there's this traditional medicine demand. More importantly is what we call this face consumption, where wealthy individuals within the Far East, particularly in Vietnam, use the possession of rhino horn artifacts to flaunt their wealth. It's, if you like, they're a newly wealthy economy, and these people want to be able to flash their status by saying, oh, we can put ground up horn into our favorite drink so we can use it as a hangover cure. It's the alcoholic drink of millionaires. And this is what's actually driven much of the demand over the last 10 years or so, which has led to a massive increase in poaching. There is also this group of young, sort of upper class of wealthy young mothers who keep rhino horn for medicines to treat fevers. And then there is, I think, another one of these issues, which I think where the use of the radioisotopes comes in, is the giving of expensive gifts that have been made out of rhino horn as rhino horn to engender favour with business colleagues. So this is, if you like, the supply chain, and I think this is where it perhaps becomes more interesting to people like yourselves in how we use isotopes, is that when you look at this supply chain, you will begin to see there are a number of points where horn changes hands, and obviously then it starts to be moved out of southern Africa to various different parts of distribution points globally. And if in the next map that's coming up here, you will see there are in fact a number of different transit points where these horns are being moved. And if you like to see here, in these transit countries, you will see that there are a number of countries that nowadays have a very significant nuclear security system in place, which is what we are using to help us reduce the amount of horn that has been smuggled. And so this is, as you can see, places like the United Kingdom, the United Arab Emirates, all of these areas are working actively to install and upgrade their nuclear security infrastructure. Globally, there are something like between 10 and 11,000 installed radiation monitors that routinely scan cargo, so 40-foot, the big 40-foot containers, shipping containers, which will scan suitcases, luggage, goods that are moved by air and by ship. And so this is, by using this technique, if you like, we are bringing in an additional, want of a better word, army of individuals who are well qualified to understand what a signal from their portal monitor means and what the actions are that they need to take. And so using this method, we are then beginning to attack the smuggling routes that lead to the movement of these horns to the final destinations in the Far East. So just to kind of talk to you a little bit about it and understand why it is, as a sort of radiation protection specialist and as someone who has a background in nuclear security, why I've got involved with this project and why I've taken it on. And so this is one of the key issues, is this modification of the risk perception of those people who are involved in poaching. And so just to sort of pose to you some questions, if there's radioactive material in rhino horn, will this affect the level of poaching? And my belief is, obviously, as I've just been talking to you about, that this will, because we will have reduced, we are going to reduce the demand. You know, this is the second question. Will there be a reduction in demand from end users? And I'd be very interested to listen to your comments about that. Based on the fact that a horn might be slightly radioactive, will people no longer want to possess this material? So let me just take you on to, you know, those are the key questions that we ask about this project. But let's have a look at what we call the risk perception. And I think this is quite an interesting thing for not only for, you know, our process in trying to reduce poaching, but I think it's a useful thing for those people who might be involved in both safety and security, and those people's attitudes towards those things. So this is a very basic model, but it's one actually which is quite useful. And if you like, it's recognized that, you know, a person's risk attitude, their attitude to a particular situation, is based very much on their perceived risk, what they understand about the situation, and it's perhaps not directly linked to the real risk. And so by bringing in new information to make people understand, and this is particularly something that we do on a local basis, where we will be talking to people around about the game farms and things like that. And so this, if you like, is the newly learned information. We can modify people's risk behavior when we give them new information. And so that, if you like, this is a kind of process that we call risk management. And so if we are to you know, alter someone's behavior because we alter the perceived risk as a result, here, you know, altering this perceived risk as a result of new information that they've learned, we can then alter the perception of risk and hopefully drive demand reduction. So if you like, to put it in basic terms, if we modify, if we consider risk to be a probability of being caught and the consequences of being caught, that gives us a notional idea about risk. If we make the horn slightly radioactive, then we increase the probability of people getting caught, because there's this advancing technology in detection systems, which I'm sure many of you've had some chance to have a look at, in terms of, you know, this is an area in which there is massive growth. I don't know how many of you have been involved in, you know, measuring radiation, but we've all used to use the old Geiger-Müller tubes and things like that, and how nowadays, well, that, you know, that used to be a piece of equipment that weighed, you know, 10 or 15 kilograms and took up the entire space on the research bench, and nowadays that has all been reduced down to the size of a couple of cigarette packets put together, and it has, in fact, additional processing power where it'll be allow you to identify, you know, specific radioisotopes, and that instrument will also give you, you know, a full spectrum analysis. That's how this instrumentation has been developing quite quickly. But coming back to our model then, so if we make a horn radioactive, we're increasing the probability of detection. And certainly here in South Africa, and I believe elsewhere in the world, the consequences for being in possession of illicit radioactive material are significantly greater than that is for the possession of rhino horn and things like that. Certainly here in South Africa, if you're caught in possession of illicit radioactive material, that's considered a crime against the state, and you'll be very lucky not to be then declared a terrorist. And so, if we can modify the risk perception, then the people involved in the movement of these items across the globe won't think it, will feel the risk is not worth the reward, and then they will not be involved in it. And again, to put this in a different way, by making the horn radioactive, we introduce significant new points in the tail. If you look at this chart and diagram here, you'll see that there are a number of points where traditionally poacher, so these materials are intercepted. But by making things radioactive, we then introduce these numerous other areas where there is a possibility of intercepting the horn, and then with this purple arrow at the end here, we are starting to push back on the end user. So you see we have a number of different points where we be able to influence people's behavior, and hopefully to the point where they no longer want to be actually involved with radioactive rhino horn. So, these are the questions I think that we need to ask. I'm not going to go through them because I believe, the time is, you will be able to sort of think about these in your own good time. I think the one point that I think we might want to mention though, is because horn is moved not directly from, say, Southern Africa to the Far East, but as I showed in an earlier map, there will be transshipment countries where containers are loaded on and off onto different ships to reload a specific load, or where transported air goods are moved. There'll be those countries which are sort of considered transshipment countries, and will those countries kind of continue to tolerate or even allow the movement of a radioactive material through those countries? So, as I say, in all cases, I believe the answer is no. Just a pause for thought. If there are, say, 100 sweeties in a bottle and just 3 of them are poisoned, would you still want to take the chance of removing one of those sweeties from out of it? So this is where I think we come into more into the science, and those people who are involved in radiation protection will understand and recognize those specific words of justification, optimization, and dose limits. And that goes back to my background in radiation protection. So what we're going to do, and what we're in the process of doing for this project, is we need to understand a bit more about the physiology of these rhinos. And so this is where we are, if you like, starting to use applied physics, starting to use nuclear science, because to be able to do this process, it's very difficult to do analysis on these animals, purely because they're wild, but they weigh in excess of a ton. And if you want to try and move one of these animals around, you need about a team of 20 people. But we needed to actually understand, is there movement of material from the horn of the animal into the body? Because this is going to have a profound impact on the direction in which we want to take this research and take this work, because it will then, if there is movement, then that will limit the type of radioisotopes that we can use. It will then limit it to, if you like, solid compounds rather than anything else. If there isn't, then we can possibly look at using various other methods with which to move radioisotopes into the horn of these animals. But second stage is, again, we need to do a dose assessment, because obviously if you're going to put radioactive material into the horn of the rhino there, then you need to understand what's going to be the effect, particularly on the sensitive organs in the head. So this is where we are talking with our colleagues in medical physics, because they have a number of useful programs which we can use to do some computer modeling. And so we will be using some of those sort of medical physics type programs. We will then be constructing a 3D phantom, constructing a full-size phantom. So again, we're taking some of those tools from medical physics to be able to confirm those measurements, those computer measurements that we do within obviously in the computer, and then take that work to the laboratory, where we can then construct these phantoms, which are made of tissue equivalent type materials, which we can then actually do some work whereby we could put some radioisotopes into the horn of the model, and then put like TLD chips at those parts in the head where we believe are going to be the most radiosensitive. And then this will help us identify what will be the most appropriate radioisotopes, understanding if there is movement in or out of the horn of the material, dose assessment. But not only will it allow us to identify the appropriate radioisotope, but it will allow us to identify the appropriate quantity of radioisotope that we are going to be using. So this is, if you like, is just some of the work that we're looking at, where there is material. What we have done, and you might have seen one or two articles in papers, is that we've started a process where we are using stable isotopes. So this is where we really are using sort of nuclear science. We're using the stable isotopes of carbon-13 and nitrogen-15 to use those isotopes to make an amino acid called L-proline. If you can remember back to your biology, you'll realize that proline is one of the building blocks of keratin, which is what the horn is principally made out of. And we've then taken that amino acid and then has put it into the horn. You'll see the picture there of me holding the syringe in my hand. And what we've done is there's actually a small hole drilled into the horn of this animal, and we've then dissolved the amino acid in saline solution, and I've put a 2 ml solution into the horn. And what we are doing then is collecting blood samples on a fortnightly basis, and we're taking fecal samples every day, and we are then going to analyze those in a mass spec to see if there's a change in these carbon and nitrogen ratios. If there is, then obviously that means there has been a movement from the horn into the animal, because the amino acid in the horn, the carbon and both the carbon and the nitrogen are 99.5% carbon-13 and nitrogen-15, which is significantly different from what the natural values are in nature. I think carbon-13 has a natural abundance of about 0.5% and nitrogen-15 even lower. So there you go. And then this is what we're doing in terms of dose assessment. We are working with Colorado State. There are available 2 or 3 data sets of a CT scan of certainly a white rhino, which in itself poses a few problems, because when you consider the size of the rhino head and the aperture on the average CT scanner, that's caused a few problems. But we've used the CT scanner to create these heads, as you can see there. What we're going to, that's just of the skull, because that happens to be a skull that I have of a rhino. But we've taken these CT scans of the head, and we are then using those to create a computer-based model, which we can then use to do some dose assessments with various different softwares. Because then this is obviously, when you talk to someone involved in radiation protection or health physics, first of all, we need to justify whatever dose that we are proposing to give to that animal, and that needs to be done in terms of extension of the life of this animal, allowing particularly the females to breed and multiply a number of times. They are not the most prolific of breeders. If a female rhino produces 5 calves in her life, she's doing extraordinarily well, but she needs to be able to do that over a period of about 30-35 years. And then, of course, we need to optimize whatever dose that we propose to give this animal, and then obviously set dose limits. And that's going to be quite a difficult issue, because what do you share? What do you compare doses to a rhino with? There are, it's not a regular data set like we have for the human being. So we are going to have to look at research work that has been done around Chernobyl and Fukushima and places like that. And then, as I said, we're going to build these phantoms, which we have a number of printers available at the university. We have, in fact, a large format one which we can use, which will probably be have suitable resolution for us to be able to print these a full-scale phantom of both the black and white rhino's head. Identification, then, I think this is perhaps one of the later stages in the whole project, is going to be what is going to be the appropriate radioisotope to use in this project. I have a few ideas in my mind what I want to use, but we have to follow the science and see what are the most appropriate now. And there, obviously, I think you will understand, coming from a physics background of the radiation, there are a number of questions that we need to ask. What is the availability of radioisotopes? Those researchers who've used them within your facility, I'm sure, will realize that not all radioisotopes are readily available. At what cost are they available? Because making a new system, if you identified if you like, a non-commercial radioisotope, or one that's not regularly used in research, what are going to be the associated costs in setting up a system to extract those radioisotopes? Again, also, what's the chemical form of these materials? What are the activity levels that we're going to need? What are the toxicity levels that we're going to need? And then, obviously, there's one of the most important ones is regulatory approval for the whole process, because I'm sure in India, as we have in South Africa, the control of radioactive and nuclear material is extraordinarily well controlled, and even to have micrograms of material, you'll need to have significant paperwork in place and approvals, and that's all based upon safety assessments and security assessments and things like that. And then, of course, because we're talking radioactive material, we need to think about the sort of half-life of these materials, because there might be appropriate radioisotopes which you can use, which are available, but only have a very short half-life, meaning that you would have to re-inject this type of material into the horn of an animal on a regular basis, which is not desirable. And again, obviously, to make this whole project work, we're going to need to think about sort of stakeholder acceptance, because quite clearly, those people who own and look after rhinos need to be the people who buy into something like this. So one of the key issues is that I do not want to be trying to poison everybody. I want them to just shy away from owning and possessing the radioactive rhino horn, because this is one of the issues that we're talking about at the moment with insurance companies and things like that, is their uncertainty, this sort of uncertainty of insurance companies about what are the possible risks involved in something like that. So there's one of those projects that some of you will have to deal with if you come up with sort of novel solutions to situations and where you want to use radioactive materials in a novel way. One of those brutally honest things, if when you're looking for a solution that is going to be, if you like, put into place, is it cost effective? Can we produce the radioisotopes at an effective cost? Can we get them into the animals at an effective cost? Because if it costs too much, then the people will say thank you very much, but no thank you. And again, I suppose this is, to use a horrible English expression, this is the elephant in the room. Is the whole technique licensable? Will the regulators in South Africa allow us to take this project forward to the final point where we can put radioisotopes into the horns of these animals to protect them from the poachers? As I said there. Anyway, that's a brief overview of the Rhisotope Project. It's a novel way of using radioisotopes. It certainly is, until now, something I've never considered. It steps away from the traditional use of radioisotopes in research, and thus far I think we're getting some very positive feedback from a number of people involved in it. So, has anyone got any questions?
Thank you very much, James Larkin. Yes, we have a query. Of course, we have two queries.
Yep.
One participant asks following question.
Yes.
I understand how isotopes will reduce demand for medicinal consumption of rhino horn.
Mm-hmm.
But what about its ornamental use? Is the amount of radioactive isotopes enough to deter someone from using rhino horn jewelry? Would it affect their health?
No, we are working quite hard to ensure that were someone foolish enough to make rhino horn into jewelry and wear it, I don't believe it would harm them like that. What we are really aiming for is those people to, if you like, those people who we just want them to sort of choose not to have radioactive objects in their house. I think you, as a more informed audience, would probably realize that the quantities that we are proposing to do probably won't do too much harm to an individual, but we really want to be working on the majority of the sort of international population who aren't as well educated and informed as someone's like your people in your audience, and get them to basically say thank you, no, I don't want something that is radioactive in my house, or as jewelry or something like that.
Yeah. There is another question from the same participant. Has there been any attempt to model or predict how an increased amount of radioisotopes in the environment would affect the ecosystem once the rhinos die of natural causes and their horns break down? So what would be its impact on the environment?
There will actually be very little impact on the overall environment, because you have to understand that environmental radiation is there anyway, depending on mineralization and depending on geology. I mean, there are areas, I believe, in India where the background levels of radiation are well in excess of what sort of international norms are, and I don't think that causes any particular harm to those people living there. Again, it's all about perception rather than actually trying to cause physical harm to somebody, because something like that, the very one, I wouldn't do it, two, the university would stop me, and three, then the law enforcement organizations of the country would stop me, because the argument is you're either causing grievous bodily harm or attempted murder or something like that. So I have to be scrupulously careful in whatever we're doing to ensure that it's done for the right reasons and in the right way. But thank you for these questions. They are interesting to answer there, and it's nice to see a different perspective from people rather than the average sort of journalist question. These considered questions are rather nice.
Thank you, Mr. Larkin. Any questions from the participants? Yes, there is a query in the YouTube.
No, I think there's some more. If you care to
Okay.
read, Anil,
Please,
I think there's some more in the
Yeah,
discussion
please,
box. Right, go ahead. I mean, there's some more in the discussion box.
Yeah, that's true. That's true. Have you finalized any radioisotope for this project?
Yes, we have. We've been looking at this, and for various reasons, we will probably use cobalt 60. Yes, because it's an industrial radioisotope. So, and this comes purely from my sort of background in nuclear security, is that it's an industrial radioisotope. So there can be no claim that if, for example, a driver was driving a lorry with a big container on it, there could be no argument that it was in fact that he had had a medical isotope inserted into his body for treatment of one sort or another, and it was that set it off. But the discriminators on the portal monitor will say no, that this is a industrial radioisotope and there's nothing on the manifest. So then we will then the processes kick in to actually take that container or that thing to one side for further investigation. Also, it's easy to make. Having a research reactor just down the road from where I stay, 20-minute drive away, and working with colleagues there, it's going to be quite easy to make appropriate quantities of cobalt 60, which we can then introduce into the horn. I think someone said, did I see some?
So one participant asks, instead of a radioactive material, is it possible to use fluorescence or phosphorescence material?
I suppose theoretically it's possible, but in many ways, we would rather the poachers didn't know whether the horn is radioactive or not. And I'll tell you for why. Is if they know it's radioactive, if there's obvious signs that this horn is radioactive, it's not unknown for the poachers to kill the animals anyway, because they've been tracking them for a while, and it's done out of frustration. So we would rather, if they're going to kill the animal, then they kill the animal, take the horn, and then bring it into the whole smuggling supply chain, where then we have another opportunity to intercept what's been, and to damage the smuggling routes. I see a question here. Can this be used in other animals?
Yes.
We are certainly going to be looking at the possibility of putting it into elephant tusk, because what we need, if you like, to make this a successful thing is the animal to obviously to be, if the animal is poached and it has an external feature that is attractive to the poachers, be it the tusks of the elephant, the horn of the rhino, or the antlers of some particular deers, If we can put some, small quantity of radioisotope into that part of the body, so it's not internal to the animal, then I think that would be possible.
So we have another question. What could be the physiological impact on the animal?
At this point, we are aiming that there should be no physiological impact. It comes down to it's the Shanghai protocol and things like that. The Singapore protocol, first do no harm to the animals, because if you're harming the animals by doing this, then what is the point of doing it? Because you don't want to harm the animals. You want these animals to live for as long as is for them the much of their lifespan to be able to breed, because at the moment what is happening is the rate of poaching here is in excess, or certainly rate of poaching and death by natural causes is far greater than the birth rate of these animals. So the pool of animals in the country is reducing at quite an alarming rate. So we want to try and at least bring the rate of poaching down to the point where animals are breeding faster than they're being poached. And that means that we must really work very hard to ensure that the breeding females are not in any way harmed by this process.
Thank you, James, for answering all the queries by the participants. Any more queries from the participants in WebEx or in YouTube? Okay, so if there are no queries, or just one more question. What is the timeline of the project? Yeah.
Oh dear, yeah, I'm under huge pressure from my colleagues to make this happen like yesterday. I am hoping that we can start what we call the proof of concept phase, whereby we've finished the computer modeling and some of the research using the phantoms. I'm hoping that we'd be in a position to start a proof of concept where we'll put radioisotopes into a number of selected animals on the 22nd of September, which is International Rhino Day. That's what we're aiming for, but all of your colleagues will understand that the pace of research only goes at a specific speed, and you're all reliant upon one another to get things done. In the perfect world, the 22nd of September is when we'd like to be able to say, hey, but I think if we're realistically maybe towards the end of the year, where we will be able to start putting radioisotopes into the horns as a proof of concept, and then next year actually roll this out as what we call a public benefit project in Southern Africa. And I think one of the things I'd perhaps like to share with you is, once we've demonstrated the proof of concept works, that we are prepared to work with colleagues in India and places like that to try and help protect the Indian population of rhinos, as well as obviously here in Southern Africa and East Africa and elsewhere in Africa. We will make these systems available to them, and we will teach them how to do it, all for nothing.
Great, that's so nice of you, Professor Larkin. Any more questions from the participants? Okay, so if there are no more questions, I request the participants to unmute themselves and thank the speaker.
Well, thank you very much indeed for allowing me to talk to you people. I much appreciate it.
I take this opportunity to thank the speaker for spending his valuable time and for readily agreeing to deliver this talk and share the details of the Rhisotope project with the audience. And I thank all the participants who have joined through WebEx and through YouTube Live, expecting this kind of support for coming lectures as well. So once again, thanks to one and all.
Thank you very much.
Thank you. Thank you so much.
And go safely. Go safely, and please stop make sure you don't stay away from this damn virus.
Yeah. Yeah. So
Okay.
Pooja, you can stop the live. Yeah. So, yeah, Professor Armugam, anything else? Now you have stopped the live.